The next possible question that the interviewer might ask is about design a shortening service like Bitly. So basically, the Bitly it takes a URL and returns a short version of it, a short URL. Redirections takes a short URL and redirects it to the original URL. And custom URL and high availability of the system. It should be always running. All right. Here's the use case or the information gathering. Additional use cases, analytics. It provides reports. Automatic link expiration, or sometimes they call it automatic link expiration or expiration. Depends, all right? Manual link removal. So it removes, you can remove manually the link. And specific company URL, specific company, so it's customized or something like that. And user interface or just the API, the application programming interface. Requirement analysis and math. First, I think this is missing T. First, we need to find the usage pattern, right? Second, you can, well, before that, let's see. You can directly ask this data from the interviewer, so something to be asked, all right, during the interview. Or you can derive it using some data that the interviewer provides. Either you obtain it directly or you obtain it indirectly based on information. Do not conclude, right? We mentioned that before. Let us suppose, do not assume, all right? Let us suppose that the interviewer tells that there will be 1 billion requests per month. So that's another question that we may raise. How many requests per month? And let us suppose the answer was 1 billion requests per month, which is 1,000 million, right? In addition, out of these 10%, out of these 10% times, it is a new request, and 9 of the time it's a redirection of the already shortened URL. So 90% redirection, 10% new request. Let us write down the data we get. Let's write the information that we get from the interviewer. 1 billion requests per month, 10% are for the new shortening, for the new URL shortening, 90% just redirection. All right, new URLs per month is 100 million from this 10% of the 1 billion, right? Requests per second, 1 billion divided by the second 3, right? Yeah, we just convert to seconds. This is per month. The month is 30 days. The day is 24 hours. The hour is 360 seconds, right? Roughly, you can assume 400 requests per second. So pay attention to this roughly, right? Because not all the months are 31. And yeah, let's proceed. Total number, of course, to get a precise answer for this, we multiply the monthly times 12, then we divide over 365 instead of 30, right? Then we keep this part. Anyhow, let's proceed. Total number of URLs stored in 5 years. Total number of URLs stored in 5 years is 100 million new URLs times 12 months times 5 for 5 years. So this is for the year. This is for 5 years. It will be 6 billion URLs in new URLs, right? Stored in 5 years. And the rest are just redirections, all right? Let us suppose the space required by each URL is 500 bytes. So we are trying to get the space complexity or the storage, the total storage, right? Let us suppose the space required by each hash code for corresponding URL is 6 byte long. This is a hash code, so we need hash code, right? And we need text storage for each URL, right? Total 6 byte just for the hash code, 6 byte long, and 500 byte long for the URL. All right. Total data we need to store in 5 years is 3 terabytes for all the URLs and 36 gigabytes, I believe. So these should be both uppercase. For hashes, because we did not mention bits, so it's bytes, should be uppercase, right? And here's the math. New data write request per second is equal 20,000, 20K per second, right? All these are what? The use case and the constraints. So the basic design. Web server provide the website for the Bitly service where users can generate short URL. Application server provides for the following services: shortening service, redirection service, and key equals the hash function, right? So we need web server and application server so far. And of course, always we need a database server. Always we need database server. And the database server keeps track of the hash to URL mapping and works like a huge hash table, stores the new mapping and retrieves the old mapping given key. So just like a phone book, right? From the old to the, from something to another something, right? And the bottleneck, what are the bottleneck in this system? Traffic is not much. Data storage can be a problem. The storage is huge. The traffic is not much because it always sends 500 bytes. That's not huge. It's not video streaming, it's not audio streaming, right? Scalability, application server start with a single machine, single computer. Test how far it takes up. Do a vertical scaling for some time, enhance its ability, add load balancer and a cluster machines to handle spikes and to increase availability. Why do we need to increase availability? Because it should be highly available. It should be always up. Data storage. Billions of objects. Each object is fairly small. There is no relationship between objects. Reads are more than writes. Of course, it's 9 times, right? And 3 terabyte of URLs and 36 gigabyte of hash tables. MySQL database, it's a relational database. It's widely used, mature technology, clean scaling paradigms, master-slave and master-master, used by Facebook, Google, Twitter, etc. So MySQL is okay. Index lookup is very fast. Index lookup is very fast. Mapping from the hash to URL. Use only MySQL table with two fields. These are the two fields. Create a unique index on the hash. We want to hold it in memory to speed up lookups. Vertical scaling of MySQL for a while. Vertical, like enhance the same computer. Partition of data into many partitions. Master-slave, read from slave and write to master. Eventually partition the data by taking the first character of the hash module, the number of partitions. And we are done with the bit.ly example. In the next video, we will record about stock query server. That's another interview question.